Hi guys, so this week we're going to be looking at how to multiply polynomials using the area model. So you guys have already looked at the area model in that launch for this week in the Notice and Wonder. So you saw on one side of the page there was just a regular rectangle with sides that were all numbers, and on the other side of the page you saw some polynomials where you had x's and numbers mixed together. So that's what we're going to be looking at today. So we're going to look at four different examples because they're all a little bit different, including one that's a word problem, just to help you set those up. So first thing here on this slide, we have multiplying polynomials using the area model or box method. So those two names are used pretty interchangeably. So sometimes you might hear somebody say area. I a lot of times just call it the box method, but they do mean the same thing. So if you notice at the bottom of the page here, we have a square. So we're going to be multiplying this 2x minus 3 times x plus 4. So we're going to be multiplying these two binomials together. Okay, so these two here. You would use a 2 by 2 area model. So meaning when you set up your box here at the bottom of the page, you have two boxes on the side and two boxes on the top. So we're going to start filling those in. And don't mind me, I am using a slightly different technology right now. So I'm trying it out. So our first one here, I'm going to fill in 2x. Ooh, that's really thick. Hold on. So we have 2x. And let's make that a little thinner. Okay, and then minus 3 would go underneath. Oh, that's better. And on the top, we would have x plus 4. And I like to bring my signs, positives and negatives with me just so I remember what they are. So what we're going to wind up doing is finding the area of each and every one of these little boxes here. So the 4 boxes. So in order to find the area of this first box, we're going to multiply 2x times 1x. And if it helps you, you can draw in the coefficient if it's missing, as well as the exponents. Okay, so when we multiply 2 times 1, that gives us a positive 2. X to the first times x to the first, we're going to add our exponents. We get x to the second power. So then we go ahead. I like to work across and then do the bottom next. It's up to you, but you're going to find each and every area of these little boxes. So this box right here, one side measures 2x, the other side measures 4. So 2x times positive 4 gives us an 8, and then we bring the x along with us. Okay, so we still need to attach that. So then I like to work across the bottom next. Negative 3 times positive 1 gives me negative 3x. And negative 3 times a positive 4 gives me a negative 12. So the last thing, this kind of looks funny. This doesn't look like a polynomial, our answer. So we've got to make sure that we put this back into polynomial form. So this comes back to our like terms that we dealt with before. So as I look at this one, my first box here has a 2x squared. Although I have other x's in this problem, neither one of them have the x squared, so that doesn't have any like terms. So I'm just going to bring that along, 2x squared. Then along here, I've got negative 3x and 8x. I like to remember in here that this makes a plus sign. So I'm adding these like terms. Negative 3 plus 8 gives me a positive 5. When I'm combining like terms, I bring my x's along with me, but the exponents don't change, so they're going to stay the same. Last but not least right here, this negative 12, that doesn't have any like terms. There's no other constants, so I'm bringing that along for the ride as well. So my final answer for this is 2x squared plus 5x minus 12. So when we multiplied this binomial times another binomial, our answer wound up being a trinomial, which a lot of times is what we're going to have. There's like one case where that doesn't necessarily work out. But here we have a binomial times a binomial gave us a trinomial. So if we look at this next slide, there's just a couple things here to make mention of. Okay, so your box is going to depend on the size of your polynomials being multiplied. So in the last problem, we had two binomials. So our sides of our boxes, the side and the top, both had two boxes across it. But we could also have a binomial times a trinomial, which would change our box a little bit, and we would then have a 2x3 box for our area model. So when we're multiplying this, we're going to place what's being multiplied along the outside of our box. So the left side or the top. We're going to multiply each term, so find the area of each term in the box or each of the boxes, and that's what we fill in with each area. And then the last part, we're going to do exactly what we did before. So we're going to take it out of the box. We're going to write our answer in standard form by combining, adding any like terms. And we're going to work when we're dealing with standard form here. Just a that's not good. Just a refresher, standard form means the highest exponent down to the lowest. So highest to lowest exponent. Okay, so we're going to look at an example next where we're dealing with a binomial times a trinomial. So I even started setting this up. So notice this time, because we're dealing with a binomial, so it has two terms, and a trinomial that has three terms, that our box at the bottom looks different. On our side, we have two terms here, two boxes. On the top, we have 1, 2, 3 spaces for our trinomial. You could also draw this the other way if you wanted to. That's up to you. I tend to draw my rectangles in this way. Probably just it takes up a little less room on my paper. So here, I'm going to switch colors. Okay, so first thing before we start multiplying is we're going to fill in our binomial. So on the side, I've got x and minus 3. On the top, where these spaces are, I've got my 2x squared. I have my minus x, and I have a plus 5. So now, before I get started, I'm just going to fill in a couple things that might be missing. Here, I'm missing a 1 for my coefficient, so I'm going to draw that in. This x is also missing its exponent. It's invisible, so I'm going to draw my 1. Here as well, I've got a negative 1, and this is x to the first power. When you start to get more used to this, you don't necessarily have to do it this way, but when you're starting out, it's helpful to see where everything comes from. So now we're going to start multiplying. So the first box right up here, I'm going to find the area of that. So I'm multiplying the two sides. I've got 1x to the first times 2x to the second. Well, 1 times 2 is 2. X to the first times x to the second becomes x to the third power. I'm adding those exponents. And I'm going to work along the side. So now I'm finding the area of the second box. 1x to the first is the side. Negative 1x to the first is this top. Well, 1 times negative 1 gives me negative 1. X to the first times x to the first, when I add my exponents, it now becomes a 2. Moving along to this last box on the top row, I've got a 1x to the first on this side and a positive 5 on the top. Well, 1 times 5 gives me 5. There's no x here, but there is one on the side, so I'm going to make sure I have x or x to the first power if I want to write that in. Now I'm going to do the same thing at the bottom. This row goes a little bit faster usually, especially when all you have is a constant. There's no x, so you only have to worry about multiplying the fronts. So that kind of gives you a little bit of a break. Negative 3 times positive 2 gives me a negative 6, and then I bring my x squared along. My next box, I have a side of negative 3. A top of negative 1x, negative 3 times negative 1 gives me a positive 3, and then I have my x. Last but not least, I've got a side of negative 3, a top of positive 5, negative 3 times positive 5 is negative 15. So last but not least here, and I'm going to switch colors, is we are going to combine our like terms and write out our final answer. Ooh, there's a purple. Ooh, maybe. There we go. So when we're looking at this, I'm going to take it piece by piece. So my first one here has an x to the third. When I look across, I don't see any other x to the third powers. So in my final answer here, it's going to start off with 2x to the third power. So then we go to our next part. So I see here I've got an x squared and an x squared. So these right here are like terms. So we're going to add these two together. So this is where we've got to be super careful with our signs. -6 plus -1 gives us a -7. Then we have our like terms, x to the second power. Exponent stays the same. Well, then along this diagonal, I've got a +3 plus a +5. 3 plus 5 gives me 8. So now I've got 8x. Last but not least, I have this lonely constant that just comes down at the end. So that would be our last term that we write, is that -15. So now that it's all written out, I can see this is in standard form. It goes from the highest exponent right down to the lowest. Okay, when we're setting some problems up like this, we've just got to check ourselves. So we have to remember what exponents do and what they really say. So in this example, we got to remember, how would we multiply x minus 5 to the second power? So when I look at this, the first thing I notice is that 2, that squared, is outside of the parentheses, which means that the whole parenthesis is getting multiplied by itself. So it's really going to look like this. This is probably one of the most common mistakes that people make when they're multiplying these binomials. They kind of forget that x minus 5 squared means that the whole thing is getting multiplied by itself. Instead, what they sometimes do is do the x to the second power, the -5 to the second power, and they miss that middle term. So when we do it, we've just got to be careful that both the side and the top would be the same. Okay, so we'd have x minus 5 times x minus 5. So why don't you guys pause this real quick, give this one a try. Draw a square on your paper and multiply x minus 5 times x minus 5. Okay, so as you guys pause that, just a couple quick things. I'll go through this one kind of quick. We have our ones. I'm going to fill in my exponents as ones. So 1x to the first times 1x to the first gives me a +1x to the second. 1x to the first times -5 gives me -5x, or x to the first if you wanted to keep it. Down here, oh wait, -5 times x to the first. Well, that looks familiar. That's -5x again. -5 times -5 gives me a +25. So last but not least, when we do our final answer here, we're going to start writing it out in standard form. So I'm going to start with my x squared, or 1x squared. On this diagonal here, I have like terms again, which happens to be where they usually are. I'm adding them together. -5 plus -5 is -10. And then I bring my plus 25. Last but not least, guys, I just want to make sure that we can see a word problem and that they're really not too bad for these, just so that way you see it. So the last thing is, in this word problem, we have a rectangular garden, which they really like gardening in these types of problems. So a rectangular garden has a length of x plus 6 and a width of x minus 2. Determine the area of the garden. So we've been doing this whole time, but if in case you forgot, when we're talking about area, we're talking about the length times the width. So I get to decide. It doesn't matter which one I put here. I'm going to put my x, we'll start with +6 on this side. On this side, I'll do my x minus 2. You could have those switched around on your sides, and that's okay. This is one of those ones that you're going to see a lot in these problems, x times x, or 1x to the first times 1x to the first. And it will start to get pretty simple when you see it. So you'll probably get to a point where you don't need to write in the ones, but for right now I am. 1 times 1 gives me 1. X to the first times x to the first gives me x to the second. 1 times negative 2 gives me negative 2x. Then I have positive 6 times a 1x. So same thing as I did before. I'm taking the area of each one of these little spaces in here. So I'm multiplying my two sides. My last side here is positive 6. The side from the top is negative 2. 6 times negative 2 is negative 12. So now I'm going to write this in standard form. So I'm going to start with my x to the second power. Then I'm combining my x's. I've got a 6x plus a negative 2x. So 6 plus negative 2 is really the same thing as saying 6 minus 2, which is a 4. So positive 4x. And then last but not least, we're bringing down that negative 12. So then once again, I can see I multiplied two binomials together, and now I've got a 1, 2, 3, a trinomial. So as you guys are going to be working this week, one of the big things that you're going to be doing is multiplying binomials, multiplying even a binomial times a trinomial. So you guys will be drawing a lot of these boxes and finding the area of each part. As always, if anybody has any questions for me, you can email me, you can message me on my Rhines, you can leave me a message, but we'll be posting both this video and I'll post the notes that we just did too, so you have something to look back at. Okay, guys, I hope everyone has a wonderful week, and let me know if you have any questions.